Alright, let's look at the ODE practice problem number 4. Alright, so we want to find the interval convergence of the following power series. Alright, so let's do that. Alright, so as usual, I'm going to use the ratio test here. So I'm going to do a ratio test. Alright, so we're going to do a limit. Right? Can I just dive right into the expression? So it's an absolute value, right? So an plus 1. So we have all these guys. We have it's going to be 2n, right? So 2n times n plus 1. So it's a 2n plus 2 factorial, right? C0, assume that's just a constant. Then you have x to the n plus 1. And over, we have 2 to the n plus 1, right? And divide by an, so I'm going to just take the reciprocal of that guy. So you have 2n factorial, put it on the bottom, c0 is on the bottom, x to the n is on the bottom. Then you have a 2 to the n on top. Right, with the absolute value sign. Alright, then we can do a bunch of cancellation here. So you have 2 to the n, and we can scratch that out. So you have extra 2 left on the bottom. Right, C0 and the C0 cancel out. Right, then you have x to the n, and then you can cancel out. So you have extra x sitting on top. Alright, then this might be a little bit tricky, but 2n plus 2 factorial, right? So let's rewrite this guy as, right, 2n plus 2 times 2n plus 1 times 2n factorial, right? So here, so we have, we can cancel 2n factorial and 2n factorial, and you have those guys left. All right, so this is going to be equal to. All right, so limit. Actually, before we do that, let's pull out all the constant. All right, so you have an x there, so you have absolute value of x on top. Right, then you have a 2 on the bottom, so I'll just pull those out. Then you have a limit as n approaches infinity, right? Then what's left is 2n plus 2 times 2n plus 1. All right, so you can see that this guy is actually getting larger and larger, right? Because n is going to be really, really big, and the 2n plus 2 is going to be big. 2n plus 1 is going to be big. Big times big is even bigger, right? So this guy goes to infinity. So only way we can get a convergence would be when x equals 0. So we would say, so this is going to be infinity if x is not equal to 0, right? Because if x is 0, the whole thing is 0. But if you have a non-zero number, this guy blows up, so the whole thing is going to blow up, right? So in this case, radius of convergence is going to be 0. So I guess interval convergence would be just one number. So you gotta say therefore interval of convergence is going to be a single number, which is just 0. Right? Any other number wouldn't work. Right? So this is a little bit a tricky one, because the radius of convergence happens to be 0. But if you plug in 0, in this case, because this power series is centered at 0, it's always going to converge, because if you plug in 0, all terms are 0, so the summation is going to be 0. All right, that's it. I hope that this was clear.